Thank you for joining PcVue Tutorials. A building management system is a perfect example of a project with generic parts. Different floors, and each floor contains similar objects such as light devices or HVAC devices connected to an OPC server, for example, in which it's possible to monitor and control. These devices are located in different types of rooms, a meeting room or offices in this floor, or just an open space in this one. And thanks to generic symbols in the structures of the variable tree using a branch system, PcVue has built-in tools to make this configuration easy. But today's customers need to reduce time of development as well as the risk of errors, especially when developing similar projects. They must be able to maintain projects efficiently, which can change at any time. That's why the version 10 of PcVue has introduced the Application Architect, a new tool to complement the existing configuration tools. It can be used to generate a structure part or all of the supervisory project by designing and instancing templates to model real objects from the process to be supervised. Without any script, through simple steps, you create and instantiate templates of reusable objects, associating not only the graphics, the symbols and mimics, but also creating all the standard configuration elements such as variables and behaviors, events, archives, and so on. And as you'll see through the different tutorials, it's always possible to differentiate templates with parameters or to customize instances to meet new project constraints and to synchronize an existing project or even create a new one without starting over from scratch. We'd like to create a building with different floors containing several rooms and devices. The project contains a mimic template and symbols from the library. Devices are a fan animated with 2 variables and a light also animated with 2 variables, and an office room. And we're going to see how easy it is to generate our project using the Application Architect. Open the Application Architect from the Configure menu. The left pane is used to display and select existing templates and parameters. The right pane is used to design the templates, the parameters, and the instances to be generated. The first step is to create the templates. Templates can be organized with different categories. It's not mandatory, but it helps to structure the template. Right-click the library local to the project and add a category. Devices. We create another category, Locations, and we now create our template. Right-click on Devices and add a new template. Enter a name. For example, we'll enter Light. As you can see, a template defines the following elements: configuration elements such as variables, thresholds, trends, cyclic and event actions, expressions, and so on. Graphic elements such as symbols and mimics. And included templates are used to structure templates in a modular manner, and parameters are used to define dynamic properties. Our light is defined with 2 variables and a symbol. Right-click on the configuration elements and add a bit variable. Enter a name. And as you can see, it's possible to define here the main properties for the variable. For example, this variable must be in command. And if you right-click on the panel, you can click Advanced and access to the advanced properties for the variable. We will now create a variable for the status of the light as shown. Now we will create a symbol attached to the template. Right-click on Graphic Elements and add a symbol. Then select the symbol from the library. And that's it. The light template is now ready. In a similar manner, we create a template for the fan. It's important to note that the variable names entered here must match the names used in the animation of the symbols. In a real project, it could be interesting to design more complex templates, including other templates. For example, we define a template for the office room. In this building, we assume that the office contains one light and one fan. A template can include another template, which is very handy. No need to recreate the devices. We just have to include the existing template as shown, one for the light, and one for the fan. The office template also uses a symbol selected from the library. We then define a template for a floor containing a mimic based on a template mimic. It'll be used to generate each floor. Right-click on the graphic elements and add a mimic, floor mimic, and then select a mimic template to be associated with. Our templates are now ready to use. We just need to configure what's going to be generated. From the Instances tab, it's possible to define a topology of our building and add the different elements to be generated in the project. We add a building, which is not an instance of a template but an element to the structure of the data. And we add an instance of the template floor. And two instances of the template office as shown. You can instantiate several instances of the same template using the multi-instance tool, which is very handy. Select the template and enter the number of instances that you need. And that's it. The two offices have been created. And on the right, we can see the elements which are going to be generated in the project. As you can see, each office includes all the elements from the included templates, fan and lights. We can now generate the new configuration. From the menu tasks, open the Generation dialog box. From here, you can set different options for the generation process. You can check the consistency of the configuration to be generated before the generation. Generate graphical elements, and in some cases you may not need to generate the graphics. You will untick this option. Two types of synchronization are possible. The fast synchronization updates only the properties that have changed, and the full synchronization generates all the configuration and overwrites the existing one. We select full synchronization and validate. And that's it. Our configuration is now generated. Let's take a look to the Application Explorer and see what has been generated. In the Variable section, a branch building has been created containing a floor and two offices. Each office has a fan and a light as devices with the variables. The real-time database structure has been created, automatically reducing the risk of error. And also, if we open the Mimic selector, we can see that a mimic for the floor has been generated. And all the symbols as well. You just have to move the objects in the mimic and it's done. Plus, if you synchronize your project, you won't be able to remove your objects. PcVue will keep them at their exact same location. For example, let's consider this existing project of a building management generated using the application architect. The symbols have been instantiated in the different mimics, and they use variables created with the application architect, such as command and status for the light. As you can see, similar branch structures have been generated as the instances of different models are defined in the application architect. We will show more of this later. The customer needs more functionalities. He'd like to be able to control the lights not only with a switch, but also with a dimmer. Plus, he'd like to display an alarm after a certain time of use for the light and then record this time. The first step consists of changing the symbol of a light. Switch in Design Mode and open the Graphic Explorer. Click on a symbol. In this one, for example, you can access it from the list within the Graphic Explorer, which is a very handy tool to access the properties of any objects inside the mimic and to be able to change the properties of any symbol. It's even possible to add animations from here. In this symbol, we have a rectangle on which we add an animation to open a pop-up. We select an existing mimic in the building library containing a dimmer. This pop-up will be opened from a generic symbol, and we will use the star character to open the pop-up using the branch of the symbol. And the first modification is done. As you can see in Run mode, if you click on a light, the pop-up appears. At this stage, the animations are not connected because the variables don't yet exist, and we'll use the application architect to generate the variables to be connected. The second modification to meet the new constraints is to add an animation to display an alarm. For example, we'll do this with an animation color on alarm. The variable will be called working time high and will be generated with the Application Explorer, as we will see. And that's it. We've changed the symbol to meet the new constraints and to animate the new variables that the Application Architect will generate. The second step consists in working on object models to generate the elements of the configuration used for the new functionalities. And it's exactly what the Application Architect was designed for. Open the Application Architect from the menu Configure. The left pane is used to display and select existing templates and parameters. The right pane is used to configure the templates, instances, or parameters, as we'll show you. This project already contains templates of objects within the library building, organized in different categories, and defining different elements to be generated. We have devices for light and temperature. The light model defines two variables in the configuration element section. We'll see that this section can also be used to define behaviors such as thresholds, trends, cyclics, and event actions, expressions, and so on. In the graphic element section, an associated symbol is defined for the light. It's a link to an existing symbol in the library. And the HVAC model defines four variables, 2 bits and 2 registers, as well as an associated symbol. We also have different models of rooms, defining the different types of rooms for the building. For example, we assume that a meeting room contains 2 lights and 1 HVAC device. And as you can see, a template can include other templates, which is very handy. No need to recreate our devices. Using the included templates, we can then structure the templates in a modular manner with a different set of lights and the HVAC for the rooms. Each template of a room also has an associated symbol specific to that room. Within the structures, a building model is defined with an associated link to a mimic to generate the building screen and a template for the floors with an associated mimic to generate the floor screens and associated symbol, which is the floor button. All these templates have been used to instantiate the different part of our building and generate the associated configuration variables and mimics in the project. We are now going to modify the templates to meet the new functionalities and synchronize the configuration. First, we'd like to control the light with a dimmer, and for that we need to modify the light template and add a register variable to be controlled. We right-click on the configuration element, and then, for example, we add the register control. The properties for the variable are displayed here. We set the variable as a command, and in our demo, the variables are connected to an OPC source as defined here in our template, with the server and group associated. The item ID will change depending on the building and floor, and obviously, instead of using a static name, it would be much more powerful to be able to set a dynamic name which could be generated depending on the branch of the variable to be created, for example. To do so, we can select a parameter from the list of parameters defined for the project. And this parameter has been defined here in the parameter section as shown. The variable to control the light is now ready. And the second constraint is to display an alarm after a period of use for the light. We create another register variable to get the time of use that we will call working time. We add to this variable a chronometer behavior with a period of 1 second. We also need to define a triggering bit, and once again it would be great to dynamically create the name for this variable. To do so, we can define the name with an expression that we create using the expression editor as shown. The control space shortcut allows us to select different functions like the name of the template and the full branch. As you can see, expressions are a good way to customize properties. The chronometer is now ready, and the last step to define a threshold to trigger an alarm. We added a threshold system to our working time variable, and we can activate a high threshold with a value of 10 as shown. The associated variable must be defined as an alarm, and the customer also needs to record the time of use for the light. If you right-click on the variable working time, you can add the variables as a trend to be archived in a proprietary format, for example, in an existing archive unit as shown. And that's it. Our model light now is ready. All the modifications we have done will be applied to the project on the next generation. Now let's take a look at what we're going to generate. The instance section contains elements generated from the templates. We already have instances for a building with 3 floors here, and it's possible to add a new instance, for example a terrace. We select a new instance from the template floor and we call it terrace. This terrace will contain one room, which will be a meeting room, but a special one, a solarium. And as a solarium, it doesn't need lights, so from the predefined template we can unselect the light models for this instance. And then from this model, only the elements from the HVAC template will generate. And this is a perfect example of customization the application architect allows to offer a full flexibility. It is also possible to delete some existing instances. For example, the meeting room and the open space of the floor will no longer exist in the building, and as you will see, it will automatically be removed from the configuration and the mimics. Modifications are done, and we can now generate the new configuration. From the menu Tasks, open the Generation dialog box, and from here you can set different options for the generation process. Check the consistency of the configuration to be generated before the generation, and generate graphical elements. And in some cases you may not need to generate graphics. For this you will untick this option. 2 types of synchronization are possible. Again, the fast synchronization updates only the properties that have changed, and the full synchronization generates all the configuration and overwrites the existing one. We select the full synchronization and validate. And that's it. Our configuration is now generated. From the Application Explorer, we can check the new configuration of variables. We can see that the terrace has been created with the solarium and the HVAC system. Also, floor 1 contains offices only now, and the lights contain the new variables that we needed to control the dimmer with the behaviors defined within the application architect. Not only variables have been generated and modified, but also the mimics. We open the main mimic, and a new button here for the terrace has been created. For example, you can now drag it here, switch it to run mode, and open the new mimic created for the terrace. As you can see, the application architect has instantiated the symbols for our solarium, a meeting room, and the HVAC as defined in our model. Now we just need to drag our symbols and save our mimic. Let's check floor 1. The mimic has been updated. The open space in the meeting room have been removed. We can check that the pop-up for a light is now animated with the new variables created and that we control the light with the dimmer. Wait for a few seconds and an alarm appears on the light. Our project has been successfully updated with the application architect. And thank you for joining PcvueSolutions tutorials.